Don't be suspicious.
Don't be suspicious.
Don't be suspicious.
Don't be suspicious.
Don't be suspicious. Don't be suspicious. Don't be suspicious. Don't be suspicious.
Hi everybody, welcome back to our virtual learning. So hopefully you enjoyed that TikTok of my two cats, Pina and Coco. So last week we talked about solving equations, and one big thing we noted about equations is that they have an equal sign. Well, today we're going to move from equations to inequalities. And to kind of get you thinking about this, I wanted to give you an example based on my cats. So we'll start with what's equal about my cats. So my cats get the same type of food. They're both able to roam around the house as freely as they want to. And we love them both very, very much. So that would be what I consider equality about my cats. Now, let's talk about what's not equal about them. Well, Coco, who's down here in the right-hand corner, gets not a lot more food, gets some more food than Pina over here, because Coco's just a bigger cat. Coco weighs almost 11 pounds, and Pina only weighs about 8.5 pounds. Pina, over here, likes to spend more time around people during the day. She's much more of a social cat. Coco usually likes to stay hidden in our bedroom, either under our bed or in the closet most of the day. And another thing that's not equal about them, or that's different about them, is Pina, so over here, gets brushed more often than Coco because her fur is longer. You might can tell from the picture, she's just got a longer coat. So there are some things that are equal, some things that make my cats equal, and there are some things that make them unequal. Okay, so we're going to talk about inequalities today, and when we're talking about inequalities, the two sides of our inequality may not be equal to one another. In fact, a lot of the times, the reasons we use inequalities is because our two sides of our inequality are not going to be equal to each other. So I want us to start thinking about this, and we're going to use this example. So it says Miss Oliver needs to have her cats at home for at least 42 days before she can take them to the vet for a checkup. She's already had her cats for 30 days. All right, so I know that I, Miss Oliver, have already had my cats for 30 days. I need to have my cats for at least 42 days. I'm going to underline that, at least 42 days, before I can take them to the vet. Well, let's think about this. If I have them for 10 more days, is that going to be enough? Well, 30 days plus 10 days would only give me 40 days. So, no, that won't be enough. I'm going to have them more than 10 days. Oh, what about 12 days? So 12 days, that would give me 42 days on the dot. So yeah, sure, that would work. But what about 15 days? If I had them 15 days, I'd have them 45 days. Well, my problem says at least 42 days. That means I could have them more than 42 days before I took them to the vet. So yeah, sure, 15 more days would work. What about 100 days? Well, if I had them 100 more days, that means 100 plus the 30 days I've already had them would be 130 days. And that's still at least, 42 days. So yeah, that would work. And we could keep going with this, naming all of these different numbers that would make this true. We want to find an easier way to represent all these answers, and that's where we're going to use an inequality. So now I've just added on a couple of sentences to this problem that say write and solve an inequality that shows the least number of additional days that she has to have her cats before she takes them to the vet. And then we're going to show what that looks like on a number line. So let's start with our total. We know, actually, let me backtrack. Let's write down what we actually know from this problem. So we know, kind of already talked about this, but that I've already had the cats for 30 days. And need to have them at least 45 days. Not 45, sorry, 42 days. At least 42 days. What I'm trying to figure out, what I need to know, is the least amount of days I have left to have them before I take them to the vet. So I'm just going to stop that right there. All right. So like we said before, at least 42 days doesn't mean I have to have them for exactly 42 days. If I have them for 42 days, that will work, but I could have them more than 42 days, and that would be fine also. All right, so here's what I'm going to do. I'm going to go ahead and write down my total number of days, which is 42 days. Okay? And over here, I'm going to write down, well, I know I've already had them for 30 days. And I'm going to have them some more days. So I'm going to use D to represent however many extra days I have them. And I need to add the 30 days I've already had them plus the other number of days that I'm going to have them before I take them to the vet together. And it says that this has to be at least 42 days. So now we've got to think back to our inequality symbols. I need this expression over here to be either equal to or more than 42. So my inequality symbol needs to be my greater than or equal to symbol, because that would say this expression over here, this 30 plus D, is going to be more than or equal to 42 days before I take them to the vet. And now we're going to treat this like an equation. If I had the equation, I'm going to write this over here so you can see it. 30 plus D equals 42. Well, I would know to use my inverse operations and subtract 30 from both sides to get D equals 12 in an equation. Well, I can take those same rules and apply them to this inequality. So I'm going to subtract 30 from both sides. And when I do that, I'm left with D is greater than or equal to 12. And what this actually means is I have to have the cats for 12 days or more before I take them to the vet. Now the last thing I want to do is show what this looks like on a number line. Well, we said before, right, let's say this is 12, so we've got 13, 14 on this side, 11, 10 down below. We said before, anything under 12 would not make this true. So we know that we're going to have, let me pick a different color. We're going to have numbers that are above 12 to plug into this inequality. But let's think about 12 itself. I'm going to draw a circle over 12. If I plugged in 12 to this inequality, would it be true? Well, I'm trying to find something that's bigger than or equal to 12. So yeah, sure, 12 would work, which means I can go ahead and shade the circle in. And this would be how I represent that inequality on a number line. All right? Now, there's one more kind kind of new thing that we need to talk about before I let you do some practice with inequalities. And that's when we have an inequality that's being multiplied or divided by a negative number. All right? So, I want us to think about this. Let's change this inequality to just -2 is less than 18. Okay? We know that's true. -2, if I have -$2, that's a lot less dollars than $18. Well, I'm just going to say I want to multiply each side of this by -1. Alright? Whatever I do to one side, I have to do to the other. When I multiply -2 by -1, I get 2. Sorry, my cat's crawling under the covers. And when I multiply 18 by -1, I get -18. Now, if I look at this inequality, I know how 2 is less than -18. But wait, that's not true. So what I have to do when I multiply or divide by a negative number is I have to flip that inequality symbol around every time. So instead, this should now say 2 is greater than -18. Alright, so if we're solving this inequality of -2x is less than 18, I want to take that same approach. To undo this multiplication, I'm going to have to divide both sides by -2. And when I divide -2 by -2, I'm left with x. When I divide 18 by -2, I'm left with a -9. And because I divided by this negative number, I need to flip my inequality sign. So my new inequality is x is greater than -9. And if I were going to plot this on a number line, so here's -9, there's -8, -10. The numbers that are greater than -9 are going to be the ones to the right, or the ones that we get closer to 0. And since there's no equal sign with this, I'm going to have an open circle at -9 because -9 would not make this inequality true. Alright, so you'll notice that our summary steps look very similar to the ones from last week on equations. When we're writing and solving an inequality from a word problem, we first have to think, what do I know? We've got to read that problem and figure out what we know from the problem. Second thing we have to think is, what is the question actually asking me to find? And to figure this out, we need to reread the problem and decide what information is missing. Thirdly, we need to know, what do I need to do to answer the question? We'll use a variable to represent any unknown information, and then we'll write, this says expression or equation, and it should say inequality that represents the problem. And then lastly, we need to solve the problem for the variable. And we do this by thinking, how can I undo this problem? Alright, go ahead and pause the video where we're at. Take a few minutes to try and solve and graph these inequalities, as well as work on this last word problem, and then we'll come back and go over it together. Alright, so here are the answers to our practice problems. So, number 1, a is greater than or equal to 8. Number 2, -4 and 5/10 is less than b. Number 3, x is less than -13. Number 4, 23 is greater than or equal to g. And then for the last one, you should have gotten t is less than or equal to 8. Now, I will go over these, but if you feel good about them and you want to go ahead and try some practice problems, you can skip to the end of this video and get your Khan Academy practice so you can get started on that. Alright, so we'll start out by just looking at the ones where we're solving and then graphing them. I know I didn't have them graphed on the previous slide, but we can look at that here together. Alright, so we'll start with number 1. I've got 7a is greater than or equal to 56. I'm trying to undo this problem, so I want to undo this multiplication by dividing by 7. And that's where I get a is greater than or equal to 8. So if I put this on the number line, here's my 8. 8 will make this inequality true, so I can put a closed circle there. And I'm looking for the numbers greater than 8. So I want to shade in the same direction that my inequality is actually pointing, the numbers that are bigger than 8. Okay? Let's look at number 2. So number 2, I'm going to choose a different color, says negative 18 is less than 4b. Now, you may say, well, what do I do when the number is on, or when the variable is on the opposite side from what I'm used to? Well, you still solve this the same way. We're still trying to undo this multiplication of 4b. So we want to take each side and divide by 4. Right? We're left on the right-hand side with b. Negative 18 divided by 4 is negative 4 5/10. And you may say, wait, Miss Oliver, we had a negative 18, so do we flip the inequality sign? The answer to that is no, we do not. Only when we are dividing or multiplying by a number that is a negative. So if this had been a negative 4b instead, then yes, we would have flipped the sign. But because what we were actually dividing by was not negative, we do not flip our sign. So, on the number line, negative 4 5/10, I'm going to say is right here. So, I'll call this negative 4, then negative 5. Alright? There is no equal sign, so I'm going to go ahead and put an open circle at negative 4 5/10. And it tells me negative 4 5/10 is less than b. So that means b, the numbers that satisfy b, have to be bigger than negative 4 5/10. So I'm going to shade to the right again. Alright. Number 3 says negative x is greater than 13. You may look at that and say, oh, Miss Oliver, there's no number. So what do I do? Well, actually, yeah, there is a number. Whenever we have just a negative by a variable, that really is saying negative 1 times whatever our variable is. Okay? So, since we're multiplying, I can divide both sides by a negative 1. I'm left with x on the left-hand side. 13 divided by negative 1 is negative 13. And this time, I did divide by a negative number. So I want to flip my inequality sign. And when I graph that on a number line, if this is negative 13, that would be negative 12, and negative 14. I don't have an equal sign, so an open circle at negative 13. And I'm looking for numbers less than negative 13. So that would be what we call bigger negative numbers. So numbers like negative 14, negative 15, and so on. Okay? Alright, and my last one, number 4. We've got 23 is greater than or equal to g plus 14. Again, my variable's on the opposite side, but I can still just perform my same steps. So since I'm adding 14, to undo that, I want to subtract 14 from both sides. And that leaves me with 9 is greater than or equal to g. So if I graph this, here's 9, there's 10, there's 8. I do have an equals with my inequality, so I can go ahead and shade at 9. A negative 9 is greater than or equal to g. That means g has to be numbers that are smaller than 9. So I'm going to shade to the left of 9 to show numbers that are actually less than 9. All right, last one. Miss Oliver wants to buy some new toys for her cats. Each toy costs 25 cents, and she wants to spend less than $2. Write and solve an inequality that shows how many toys Miss Oliver can buy, and then show what this looks like on a number line. So here's what I know. I know that cat toys cost 25 cents. And I know that I want to spend less than $2. Alright, so what I need to know, what I'm trying to figure out is, how many cat toys can I buy? Alright, so there's what I know, there's what I need to know. Okay. So my total that I want to spend is less than $2. So I'm going to write $2. And whatever I spend, I want that to be smaller than $2. All right. Now, each cat toy costs 25 cents. So if I bought one cat toy, that would be 50 cents. If I bought 25 cents. If I bought 2 cat toys, that would be 50 cents. 3 cat toys would be 75 cents, and so on and so on. I could keep doing that, but an easier way to show that is by taking 25 cents and multiplying it by the number of cat toys. So I'm going to represent that using a T. All right, now that I've got this inequality set up, I can solve it just like we've been doing, by dividing both sides by 25 cents. And so what that leaves me with is T is less than 8. So if I show this on a number line, I should say less than or equal to, because, well, let's go back up and look at our problem. So our problem does say she wants to spend less than $2. All right, so let's go back down here to what I said before. We do need this as a less than, because I don't want to spend $2. I want to spend less than that. All right, so since I want to spend less than $2, I need to put an open circle at 8. Because 8 toys would be exactly $2. I want to spend less than that. So I need to buy less than 8 toys. Which means I could buy 7 toys or 6 toys or 5 toys or 0 toys if I wanted to. I'm just trying to buy less than $2 worth of cat toys. Alright. So here is your Khan Academy practice for the lesson that you watched today. All right, so we're looking at inequalities from a graph, plotting inequalities. So that's what we did, where we put the inequality on the number line, testing solutions to inequalities, and then solving one-step inequalities, which is what we've been working on. Enjoy these 2 pictures of my snoozing cats. Maybe you can take yourself a nap after you've watched this really long video. Since this video has been longer than usual this week, I think this will be our only video for this week, and I'll save the other video for next week on 2-step inequalities. So focus on getting some good practice in for this week. Feel free, like always, ask us questions on our meetings on Tuesday or Thursday. And I look forward to talking with you guys this week. Thanks for watching.